Hello, students. I wanted to share with you uh, just talking about the how you use the Hess Law to analyze your data. So, if you recall from the first reaction that you performed was using hydrochloric acid plus sodium hydroxide. You produce from there like table salt plus water. And in the second reaction, you use sodium hydroxide plus ammonium chloride, and you produce from here table salt and ammonia plus water. So this one is delta H, which you should calculate from what we saw in here in the lab. So it's minus Q, which is a heat transfer, and this is equal to minus mass of the water times the heat capacity times the delta T of the experiment. And this goes also for Q, and I guess we did the reaction using hydrochloric acid and ammonium hydroxide, which in solution is this, and this reacts to form ammonium chloride. So if we develop this equation into the total ionic, equation, it would be H plus chloride ions, sodium plus hydroxide ions, and it produces sodium plus chloride plus H2O. And if we take a look, we have water here, we have sodium here, so this one cancels out. These are excitating ions. But in this case, like we see that the second reaction actually produces, I mean, it can be written in its total ionic form, like so. The anions and cations, and as a product, sodium chloride, ammonia plus water. And we see that the reaction we were interested in was protons plus ammonia equals ammonium ions. So we see here is a one reactant as a product, so we can flip the second equation. So this would be like 2 flipped. We write down all the products as reactants. And all the reactants as products. We see we have expectating ions here and here, here and here. And Scroll a little bit down. So the first equation, which is this one, would turn into H plus hydroxide ions goes into water. And this one is the first one. And the second, which is inverted, it's NH3 plus water goes into hydroxide ions plus NH or plus ammonium ions. And you can see here that if we add up these two, I mean, this one has this enthalpy, which is the one from the first reaction. And this one is a negative of the enthalpy of the second reaction because it's inverted. And therefore, if we add them up, we get ions plus NH3 plus OH minus plus water produces water plus OH plus ammonium ions. And you can see like this one cancels out with this one cancels out with this one, and we end up getting this net equation. And its enthalpy should be equal to the enthalpy of the first reaction minus the enthalpy of the second reaction. And if we remember in the other experiment, we were looking at hydrochloric acid plus this, which is actually in solution H3, goes into ammonium chloride. And in the ionic form, we have this, and these are expectating ions. So you see, reaction 3 is the same as the one minus the second one. And therefore, the enthalpy reaction 1 minus the enthalpy of reaction 2 should be equal to the enthalpy of the reaction 3. And this goes for part 4 parts.